Hello, my name is Robert Smith and I'm with New River Community College, and today we are looking at precipitation reactions and specifically fractional precipitation, or how to separate ions through fractional precipitation. So let's get started. In this case, basically the process of fractional precipitation is that you have two ions that will react, and with a either they be multiple anions or multiple cations, and they'll react with a corresponding cation or anion respectively to precipitate out of solution. And you want to precipitate one but not the other. And in this case, we want to take out all the bromide from the solution. It could have been that the solution was sodium bromide or potassium bromide that we put into water and it dissolved, and the potassium or the sodium is a spectator ion now. Same thing with the chloride. It could have been some kind of alkali metal that complexed with the chloride ions and then dissociated in water. So now we have a solution with equal concentrations of chloride ions and bromide ions. You don't have to have equal concentrations, we just do in this case. So, if you encounter this and they're different concentrations, you would still use the same procedure. And all we're doing is we are dripping in, drop by drop, silver nitrate, which is AgNO3. And nitrate is also a spectator complex ion. It'll dissociate from the silver and it'll just float around in the water and it will not precipitate out. But the silver, when complexed with either chloride or bromide, will produce a precipitant and will drop to the bottom as a solid. And so that's what we're trying to do. And in this case, we're trying to just get the bromide out and not the chloride. So what we're using here are the solubility products of the respective salts to determine how much silver nitrate we have to drop in, knowing that silver nitrate will then become silver ions in solution. How much silver ions we need in solution to get out as much of that bromide as we can without taking out any of the silver chloride or any of the chloride ions. To do that, you just do it as two different parts. And so let's start with silver bromide. So silver bromide is in equilibrium in solution with silver plus bromide minus. And again, our AgNO3, once it's in solution, it'll completely dissolve down into Ag plus NO3 minus. So we don't have to worry about our NO3 minus. So this Ag plus is the same as that Ag plus, okay? And we know that from looking it up, we know that the solubility product, the KSP, is 7.7 times 10 to the minus 13. And all we have to do is set up our KSP equation for silver bromide. And in this case, KSP is equal to the concentration of the silver times the concentration of the bromide. We don't have to worry about other ions complexing. And so in this case, we know what the KSP is and we know what the Br minus is. So we could just solve for Ag plus. And that concentration will be KSP divided by Br minus. And we get that by dividing this equation by Br minus to both sides. And that'll cancel on the right-hand side and lead to this equation on the left. So, and then just plug in our numbers. So 7.7 times 10 to the minus 13, all over 0.040. And when you run that through, you find that the final amount is 1.9 times 10 to the minus 11. So that's the concentration of silver at the point where it starts precipitating. So any concentration of silver above that point will lead to silver bromide dropping out of solution. So then our next step, so we know at the very minimum we need 1.9 times 10 to the minus 11, a little bit more than that, to get silver bromide. So now we need to know what's the maximum amount we can drop in. So instead we have AG, this should have been AgBr. So the AgCl in equilibrium with Ag plus Cl minus with a KSP of 1.6 times 10 to the minus 10. And again, we set up the same kind of equation, and we end up with Ag plus is equal to KSP over the concentration of chloride, which would be 1.6 times 10 to the minus 10 divided by 0.040. And you could see that you would just, you could put whatever concentration they actually are. In this case, they're equal, but if you had different concentrations, you just put the concentration of bromide where bromide should be and the concentration with chloride where chloride should be. So it's fairly straightforward. But once you do this calculation, you get 4.0 times 10 to the minus 9. And these should both be molar. So we now know that our concentration of silver ions, which is also equal to the concentration in solution of AgNO3, should be greater than 1.9 times 10 to the minus 11 molar, but should be less than 4.0 times 10 to the minus 9 molar. Otherwise, you'll start precipitating silver chloride ions, or silver chloride solid. So to just get silver bromide and no silver chloride, it has to be somewhere in between there. You just go just a hair underneath 4.0 times 10 to the minus 9 molar. And you would figure that out by finding the volume of the solution, and from that you would just take the moles. You would solve for the moles using the molarity, and that would give you how many moles of AgNO3 you would need.